All right. So today we are going to make a large flow chart, and we're going to talk about what is science. All right, so I want you guys to get out a piece of paper, okay, and you're going to want to write relatively small, but we are going to end up making like a huge web that's going to cover this entire piece of paper. Okay, so go ahead and get out your piece of paper. I would probably have it horizontal or like landscape style. And the big question is, what is science? How do we define science? So you should have already done the class discussion over what science is. That should be getting you thinking about what science is. And so today I'm going to share with you how I classify science. Okay. So to me, science has three big parts that are going to combine. So one of the big pieces of science is going to be the scientific processes. Okay, so these are the processes that lead us to actually learn our scientific knowledge. So we'll come back in just a minute and we'll talk about what those processes are. All right, the next branch of science is going to be the actual body of knowledge. Okay, so what do we know? So for us this year, you are in biology class. So I'm also going to put biology. Okay, so when we are talking about the body of knowledge, in this class, we're focusing on the body of knowledge focused on biology, or what do we know about life. All right, and then finally, our third branch is going to be nature of science. And I'm just going to do capital NOS also for short. Okay. So what is it that makes science different from your other subjects? Okay, so what makes something a scientific fact versus a not scientific fact? So we're going to go through these three things. And we're going to talk about how together they're going to make up science, which is what you're going to study this year. All right, so I'm going to go back to scientific processes. Okay, so one huge branch of science is what are the processes of what did we actually use to learn what we already know about science, or what do we know about biology? Okay. And so most of these are going to be familiar to you. So one of them is concluding. Okay. Another one is experimenting. A third one is going to be hypothesizing. And we'll talk a little bit more about these in depth on our next presentation. Our next characteristic is going to be classifying, predicting, we have inferring, and estimating. All right. Then we also have measuring and observing. All right, so when we look at our list of processes, so concluding, experimenting, hypothesizing, classifying, predicting, inferring, estimating, measuring, and observing. Hopefully those words are familiar to you from science classes you've taken previously. We're going to talk more about them the next time we do notes. And also, we're going to talk about these all year long. Okay, so we're going to focus on these scientific processes throughout the whole year. We're going to work on developing these skills. And then these skills are also really crucial for success in the 21st century. So we're going to work on them to help make you a better scientist in the way. And then it's also, skills are going to make you function a little bit easier in the 21st century world. All right, now we're going to jump over and we're going to look at the body of knowledge. Okay, so this year you're in biology. Okay, so when we look at the body of knowledge, we might be looking at scientific laws. We might be looking at scientific theories. We're going to look at concepts or ideas. Definitions. And facts. Okay, so this year we will look at different laws, theories, concepts, definitions, and facts. And since you're in biology, all of these are going to be surrounding the topic of biology. All right, and then finally, I saved my favorite for last, which is the nature of science. So the nature of science are really just the characteristics that make science science. Okay, so why is science different than your other subjects? So the nature of science, it's going to incorporate all these characteristics of how science is different. So one of them is there's both objectivity and subjectivity in science. So I'm going to write objective versus subjective. Okay, so objective is going to be unbiased. Okay, or it's just going to be facts. Okay, so unbiased means I'm not going to let my personal opinion get in the way. I'm solely looking at facts. There is subjectivity in science too at certain times though. So when we're looking at facts, you have to interpret those. Okay, so that interpretation is naturally going to be a little biased. Everyone's opinion is going to come into play. All right, another characteristic is going to be observation versus inference. So an observation is going to be something you can observe using your senses. An inference is going to be an explanation based on your observation. All right. Again, we're going to have theories and laws. When we do our next set of notes, I'll distinguish what's the difference between a theory and a law. So I'm not going to distinguish that on this piece of paper, but we will get to it in the very near future. All right, something else about science. It is culturally and socially embedded. Okay. So for me, this one is the hardest one. Like, what in the world does that mean? It means that our culture and our society shape a little bit about where science goes and what science focuses on. So let me just give you an example. Let's talk about COVID right now. This is a hot topic. But a year ago, do you know how many people were studying coronaviruses? That's obviously not COVID-19, but just the family of viruses, coronaviruses. So 1 year ago, there was only about 100 people on this entire planet studying coronaviruses. And then now, our culture and our society have completely changed, where coronaviruses are now a huge focus. There are hundreds and hundreds of scientists who are now studying coronaviruses. Okay, so our culture, our society has shaped where science has gone. Another one I like to point out is Ebola. How many of you remember hearing in the news a few years ago about a big Ebola outbreak? So when Ebola outbreaks are happening, there's a lot of people who drop everything and start to research Ebola. There's a lot of money funding that research. And then once those outbreaks are contained, it just disappears a little bit, right? People give their money elsewhere. So then researchers can't perform their research. All right, another characteristic of science, it's tentative. Tentative means it's subject to change. So we're gonna write it can change. So science, it is the culmination of what we know so far. But as our technology changes, scientists acknowledge that that body of knowledge we have, it can also change. So it is very tentative. And I'm going to underline, I'm going to star. A great example I have for the moment is going to be related to COVID because it's so popular. But think about face masks. When COVID was first kind of coming to America, we were first, maybe back in March, we were just starting to stay home. At first, the CDC recommended everyone wear a face mask. Then, not long after, they said, nope, don't wear a face mask, only let healthcare professionals. And then now we're flip-flop, we're back to wearing face masks, okay? Does that mean that those scientists don't know anything and they're just rolling the dice? No, okay? That's not what that means. They're not just rolling the dice. Their facts are changing as we learn more about this virus. We're learning new facts. And so then we're going to make new decisions based off those facts. So science is tentative. Okay, next. Science is empirically based. Empirically based. I'm left-handed, guys, so when I get to this side of my screen, my writing gets a little bit worse because I can't put my hand down. So what does empirically based mean? It means that our scientific facts and explanations are going to be based on evidence and data. Okay. And we get these from observations and experiments. So whenever we do have scientific facts, those facts, there are data and there's evidence to support those facts. And that data and evidence is going to come from observations or experiments. So you can't just make things up in science, or it's not an opinion. So it has to be backed up by observations and experiments. All right. Next. Science has a lot of creativity and imagination. And I know at first a lot of you probably picture science to be very dull and mundane, but really there's a lot of creativity and imagination, because once a scientist has a question or an interest, they have to design some sort of procedure of how are you going to answer your question. So you need both creativity and imagination of how are you actually going to answer this question? What kind of data do you need? Also, once you've collected your data, you somehow have to take a lot of numbers and make sense out of them and draw a conclusion. So it takes a lot of creativity to draw conclusions from just numerical data. And then finally, there are a variety of methods. Hold on, so that's a V for variety. So variety of methods to collect data. So we're going to talk about this more when we take notes in the near future, but there's lots of ways. So we can get data from descriptive research, correlational research, or experimental research, okay? So there's going to be more to come for that section. All right, so you guys should have a flow chart like this, okay? Something like this. Maybe it looks a little bit neater than mine. So what I want you to have on your paper, though, I do want you to have what is science in the middle, okay? And then we're going to have our 3 big branches of science. So scientific processes, the body of knowledge, and the nature of science. So all 3 of these are going to combine to make up science. So we have our facts, okay? So this is what we know. Our scientific processes are, how did we actually know what we know? What did we use? Okay. And then finally, our nature of science is kind of the rules of science. So what makes something scientific? What makes something not scientific? Okay, so all 3 of these combine. And so for this school year, we're going to focus on all 3 of these. Okay, we're not just going to memorize a list of facts about just biology. Okay, we're going to learn, how do you actually conduct science? So how do we know what we know? And again, like I said earlier, these are going to really help strengthen your 21st century skills. We're also going to talk about the nature of science, okay? Why some things are considered scientific, why some things aren't. Nature of science helps contribute to something called scientific literacy, which is becoming more of a buzzword right now. So how do you use scientific data to make choices for your personal life or societal decisions? Okay. So we're focusing on all 3 of these this year. So make sure you keep this chart. You absolutely need this chart. Okay. So if you haven't written this down yet, you need to get a piece of paper. You need to copy this chart down, and then you need to keep it. We are going to come back to this chart all year long, and we'll talk about how what we're doing in class ties in to where we are on the chart.